David Estrada was a young police cadet when his spinal cord was severed in a motorcycle accident. He thought his life was over.
The shards of bone from my vertebrae pierced my spinal cord, and I knew right then that I was paralyzed.
So one of the big projects of my life is to eventually develop a structure that will be able to bridge across a broken nerve, essentially restore the connection from one part of the spinal cord to another part of spinal cord in the case if it's been severed.
With support from the National Science Foundation, material scientist Polina Anikeva and her team at MIT are building a nerve repair toolkit with an eye toward repairing damaged nerves and even growing new ones.
What we're really striving to do is to have a device that becomes intimately a part of a nervous system. So you can see what's coming out, and this is the fiber.
They stretch out long, thin polymer strands that will be implanted right alongside damaged neurons.
So what we're looking here is at the tip of this fiber, you should see a cross-section which is exactly the same as the cross-section of this large template. You can see the electrodes, they're black. You can see the optical waveguide core right in the middle, and then you can see the hollow channels.
The fibers are multifunctional by design. They can include hollow channels to deliver drugs, embedded electrodes to send electrical signals, and optical guides to transmit light, switching nerve signals on and off using a method called optogenetics.
For certain stimulation frequencies, you can get neurons to grow almost 3 times as fast.
You can hit and pull and really stretch this rod to form the fiber.
Anikeva and her team are also designing fibers that can act as tiny scaffolds, 3D structures to support new nerve tissue as it grows, even accelerating it.
This is the fiber that you can see has little grooves in it. They allow the neurons to grow along them.
The ultimate goal is to help doctors treat diseases like Parkinson's, schizophrenia, depression, and heal spinal injuries.
It would be wonderful if we were able to regenerate the spinal cord and then restore the movement, or if we were able to bypass the spinal cord with a device that mimics its function.
Anikeva says repairing nerves so that someone like David Estrada could walk again will take many years to achieve. Building the tools now that will make that happen is a first step. For Science Nation, I'm Miles O'Brien.